derive a formula for a geometric sequence. So we will still use the same example as the previous one, the sequence 3, 6, 12, 24, with a common ratio of 2. Okay, so this is our a sub 1, our a sub 2, a sub 3, and a sub 4. So first off, to derive the formula for the sequence, let's have our a sub 1. Again, what is the a sub 1 in this given sequence? It is 3. Okay. What is the relationship of this common ratio in finding the next term for this geometric sequence? Yes, multiplication. If we will multiply the common ratio to a certain term, the product will be the next term, right? So let's start with our first term, 3. So if we will multiply 3 by the common ratio, which is 2, we will get 6. And 6 is our a sub 2. So this is now a sub 2. Okay? So we can say that in finding a sub 2, we will multiply it by r. Oh, shucks. Wrong. Okay. So we can say that in finding the value for a sub 2, we got that from the a sub 1. So we will multiply a sub 1 by the common ratio, which is r. So a sub 1, 3 times 2, the common ratio, that's equal to 6, which is our a sub 2. How about finding the formula for the third term, a sub 3? If we are going to use a sub 1 as our base term, what do you think will be the formula? So let's say we have a sub 1. What are you going to multiply to a sub 1 to get a sub 3? Okay, let's say we will multiply it by the common ratio r. So let's check. What is our a sub 1 again? It's 3. So 3 multiplied by 2, that is just 6. 6, which is your second term. But we are looking for the third term. So if this is 6, what can we multiply to 6 to get 12? Yes, we can multiply it by 2, which is again the common ratio. So all in all, if we are going to simplify the formula for our a sub 3, you can say that a sub 1, which is our 3, multiplied to r, multiplied to another r. And if we are going to multiply two variables, r times r, that is equal to a sub 1 r squared, right? Because r times r is r squared. So our new formula for a sub 3 is a sub 1 multiplied by r squared. While for a sub 2, we have a sub 1 multiplied by r. So I have here the formula for our a sub 2. We have a sub 1 times r. For our a sub 3, we have a sub 1 times r squared. How about the formula for in finding the fourth term, a sub 4? Okay, just like the solution for a sub 3, let us use a sub 1 as our base term. So a sub 1 multiplied by a r. Let's check. So if we are going to multiply a sub 1 by r, that is 3 times 2, which is just equal to 6. But we are looking for 24. So again, we need to multiply 6 by the r, so it will become 12. But then again, this is not 24 yet. So what are we going to multiply to 12 to get 24? Yes, we can multiply it again by the common ratio, which is 2. So 12 multiplied by 2, that would be 24. So if we're going to put this into a formula, we have r, that 1r is for this first 2. The second 2, we will multiply it again by another r. The third 2, that is another r because we multiplied the common ratio 3 times. And r times r times r is equal to r cubed. Okay, so therefore, we can say that the formula for a sub 4 is a sub 1 multiplied by r times r times r is r cubed. So you see, I want you to observe these 3 formulas. Look at the 3 formulas. If we're looking for a sub 2, we multiply a sub 1 by r raised to 1. We all know that this is raised to 1, but we don't need to write it as 1. So we have a sub 1 times r. While if you're looking for a sub 3, you have a sub 1 times r squared. We have a sub 4 equals a sub 1 times r cubed. So if I am looking for a certain term, let's say denoted by a sub n, n is for the number of terms in a given sequence. And since a sub 1 are all common from this 3 formula, we can use it as our base term, a sub 1. And then r is also common. But then again, the exponents are all different. Where can we get these exponents to make a formula? Okay, so if this is 1, observe that this is 1, this is 2, this is 3. But we are looking for a sub 2, we are looking for a sub 3, and we are looking for a sub 4. Notice that the value of the exponent is always less than 1 for the term that we are looking for. So we can say that since we are looking for a term, n minus 1. So this formula is used in finding a certain term if the given sequence is a geometric sequence. Let's have our example number 1. In the sequence 5, 10, 20, and so on, find a sub 8 or the 8th term. So let's follow these steps for us to easily, or for you to easily understand the solution. First step, find the common ratio. Find the common ratio for the sequence 5, 10, 20. We use the formula 4, which is r equals a term divided by its previous term. So we will do it until the third term since we have 3 given terms. Let's start with our a sub 2. R equals a sub 2, which is 10, divided by a sub 1, which is 5. So we have r equals 10 divided by 5 is 2. Next, a sub 3 divided by our a sub 2. So we have r equals 20 divided by 10. 20 divided by 10, that is equal to 2. So r equals 2. Second step, evaluate using the formula a sub n equals a sub 1 multiplied by r raised to n minus 1. So this formula here is the key for us to find the 8th term. So in this one, again, we're looking for a sub 8. And from the previous step, we got 2 as our common ratio. Let us identify first the values of these variables in the given formula. So if we are looking for n, this n means the nth term that we are looking for. So what are we looking for? A sub 8. So n equals 8. A sub 1, from the given, we have 5, the first term. So a sub 1 equals 5. Next, our r, again, is equal to 2. And n minus 1 is, of course, if our n is 8, n minus 1 is equal to 7. So what we need to do now is to substitute all of this to the given formula. So we have a sub n, that is a sub n, which is 8, because we are looking for a sub 8 or the 8th term, equals a sub 1, which is 5 multiplied by r. So r is equal to 2 multiplied by r, and n minus 1, which is 7. So 2 raised to 7. Now simplify. So we have 5. What is 2 raised to 7? So if you will multiply 2 7 times, what is the product? So it is equal to 128. Now the last step is simplify or multiply. So a sub 8 equals 5 times 128 is equal to 640. Therefore, this is now our 8th term, 640. And lastly, check. So we will check our answer by continuing the sequence. So for us to check this, we can use a table like this. So since we are looking for the 8th term, we have n with the first, the second, the third, fourth, until 8th term, since we are looking for 8. And our a sub n, since from the given, 5 is our a sub 1, 10 is the second term, 20 is the third term, so we have 5, 10, 20 from the given. So to check, since we got r equals 2, we will multiply the third term by our common ratio. So 20 times 2 is 40, 40 times 2 is 80, 80 times 2 is 160, 160 times 2 is 320, and lastly we have 320 times 2 is 640, which we are looking for. So from our solution and from our checking using this table, we got the correct value of our 8th term, which is 640. Let us proceed to our example number 2. The problem for our example number 2 is, if the 7th term of a geometric sequence is 30 and the 11th term is 480, find the first term and the common ratio and the 15th term. So in this problem, we are looking for 3. The first one, we're looking for the first term. We're also looking for the common ratio, and we also need to find the 15th term, or the a sub 15. Okay, let's have the first step. State the given. For our first step, state all the given from the problem. So in the problem, we have the 7th term, which is 30. So represented as a sub 7, that is equal to 30. And we also have the 11th term, which is 480. So that is a sub 11 equal to 480. Second step, find the common ratio, the first term, by dividing the two equations simultaneously. For step 2, find the common ratio and the first term by dividing the two equations simultaneously. But first, we need those equations. So we are going to use our formula for geometric sequence. A sub n equals a sub 1 multiplied by r raised to n minus 1. Okay, but we don't have a sub 1 yet. We don't know the common ratio is. So what we are going to use for this are the given in the problem, a sub 7, which is 30, and a sub 11, which is 480. Okay, so we will substitute the given to the formula. Let's start with the first one, the 7th term, which is 30. The seventh term is 30. The value, which is 30, we can substitute it to a sub n. So we have now 30. We replace a sub n by 30 equals a sub 1. A sub 1 is not given yet, so we will just write a sub 1. R, we don't have R yet. N, since we have a seventh term which is 30, we should know what is the value of n. That is 7, the seventh term. So n minus 1, that is 7 minus 1. So to simplify this equation, we have 30 equals a sub 1 multiplied by r. 7 minus 1 is 6. So we have now one equation. Let us proceed to our second given, which is the 11th term for 80. So what we did here, we will also do it for the second given for 80. Okay, so for 80, we will replace a sub n again by 480. We have 480 equals a sub 1 r. And since for 80 is the 11th term, our n is 11. So we have 11 minus 1. So simplifying this, we have 480 equals a sub 1 r. What is 11 minus 1? That is 10. So we have now two equations. These are now our equations. 30 equals a sub 1 r raised to 6. 480 equals a sub 1 r raised to 10. So we are going to divide these two equations to find a sub 1 and the common ratio. Okay, so let's do that. Dividing the two equations, we have 480 equals a sub 1 r raised to 10 divided by 30 equals a sub 1 r raised to 6. So we will simplify this equation. So let's start with 480 divided by 30. What is 480 divided by 30? So that is equal to 16 equals, since both numerator and denominator have a sub 1, you can simply cancel this, and then dividing a variable with exponent, of course, is what we do. What we need to do is subtract its exponent. So 10 minus 6, that is equal to 4, right? Next, here, what we are going to do is extract its root. So since this is fourth root, we can find it, or you can start with square root to make it simple, to make it easier. Find the square root. So what is the square root of 16? That is 4. What is the square root of r raised to 4? That is squared. But then again, we still need, what we need is only r, not r squared. So it has still an exponent. So again, we get its square root. What is the square root of 4? That is positive and negative 2. And then square root of r squared, that is r. So the value that we got for the common ratio is positive negative 2. Continuing the solution for our step 2, we have now found that our common ratio is positive or negative 2. These two equations were from the previous solution, but we are not yet done with our step 2 because we need to solve for the value of our first term, or a sub 1. So in finding the value for a sub 1, we need to use the value of our r and one of these equations that we got a while ago. So let us use the simpler equation 30 equals a sub 1 r raised to 6. So we don't, let us rewrite it here. 30 equals a sub 1 r raised to 6. So we are looking for a sub 1 here. We already know r, which is either positive or negative 2. So we will just substitute it here. So let us substitute 30 equals a sub 1. What is the value of our r? Positive or negative 2. Remember that our exponent is an even number. So even if you will use a negative value of r or a positive value of r, it will not affect the answer that you will get because it is an even number. So either you can use positive or a negative 2 as your common ratio. So I will use the positive 2 as our common ratio for this. So we have 2 raised to 6. So we are looking for a sub 1. Since this is the only variable left, we can now find its value. Okay, simplify. So we have 30 equals a sub 1. 2 raised to 6 is equal to 64. So 64. But we are looking for a sub 1, so we will manipulate this equation by dividing both sides by 64. We divide it so that we can cancel it in this part. So what we have left here is the a sub 1 which we are looking for. So 64 divided by 64, that's 1. So we already have 1 a sub 1. And 30 divided by 64, we can divide both numerator and denominator by 2. So 30 divided by 2, we got 15. 64 divided by 2, we got 32. So we simplify. The value of our a sub 1 is now equal to 15 over 32. Last, determine the 15th term using the general rule. For step 3, we will determine the 15th term using the general rule. A sub n equals a sub 1 multiplied by r raised to n minus 1. So before we use this formula, we need to find first what values are we going to substitute here. So since we are looking for a sub 15, therefore the value of n is 15. Our a sub 1, we have 15 over 32, and we have r, which is either equal to positive or negative 2. Now, for our n minus 1, of course, n minus 1 is 15 minus 1. That would be 14. So we are now complete. Let us now substitute to our general rule. So a sub n, we have a sub 15 equals a sub 1, which is 15 over 32. So we have 15 over 32 multiplied by our ratio, which is positive or negative. So let us use positive again. 2 raised to n minus 1, which is 14. So we have 2 raised to 14. So next, what we need to do, of course, simplify. So if you're going to simplify 15 divided by 32 multiplied by 2 raised to 14, you will get 7,680. You can either use a calculator for this or manually solve for it. But either way, you will get a sub 15 or the 15th term as 7,680.